Hey, what up guys, this is Nick the Quant, and today we have another video for today's highest mathematical edge pick. Video is going to be a little bit late. I posted about this on my X account. I just started work today, so as far as my schedule goes, some days I might be able to post in the evening. I'm going to be trying to do my best to actually post on lunch breaks, but we'll see how that goes. Nonetheless, yesterday we had the Baltimore Orioles on the money line. They lost, the Toronto Blue Jays on the money line, they lost. So we were at 5 straight days of profit, making crazy units, but the past 4 days, we've hit some pretty good regression. But that's all the part of this. Again, that's how probabilities perform, because it refers to a distribution of events, not just singular outcomes. So that's just the name of the game. But utilizing Kelly criterion and making sure that we're calibrating our probabilities properly allows us for the difference in these two events, right? When you're hitting that hot streak and then you're hitting a cold streak, you always want the difference to still be profit because the probabilities are accurate, meaning you have better risk mitigation in those losing periods, and then your profitability based on the odds you're betting on and things like that, how much you're risking, are being maximized when you're in those winning streaks. Saying that, today our highest mathematical edge pick is the Arizona Diamondbacks on the money line. Real quick, I forgot to do this part. My bad, boys. It's been a rush getting back. So like what my schedule kind of looks like right now is I'm waking up at 5 a.m. so I can get some of my steps in, and then I immediately sit down. Well, after I eat, I sit down, I get to work, I do today's predictions, and then I'm really on the road to work a little after 7 at that point. And I get back and try to take care of the rest of the work that I need to do, go to the gym, stuff like that, and just kind of rinse and repeat. But saying that, we can get into the math on today's pick. But I was just going to read from this notebook, honestly. That's what I was planning to do on my lunch break, but I wasn't able to. So, second. All right, let's take care of this. So, like I said, we got the Diamondbacks on the money line. I'll talk to you guys right now about the odds and stuff like that. Sorry, things are loading a little slow. Here we are. All right, cool. So we got the Diamondbacks at plus 108 on the money line. My model has them at a probability of a 53.62%, denoting an expected value of 11.53%. We're risking 2.13% or 2.13 units, utilizing that fifth Kelly for a potential profit of 2.3 units. So let's jump into the math on how I came up with these numbers, how my model came up with these numbers. So like I always say, my ensemble model is made up of 9 interior models. Those 9 interior models are calibrated based on the actual results of the initial predictions the models output. So an example of that, the Mariners game today, model 1 says, okay, Mariners 56%. But in reality, that's only been hitting 50% of the time. So that probability, the calibrated probability for that model is 50%. Now, doing that, we need to take into account the amount of sample size that these initial predictions have, because the less sample size, there's inherently a lot more variance, and these probabilities can skew significantly from initial prediction to the expectations to the reality. Again, henceforth, the distribution of events. So saying that the amount of sample size that each prediction has is what allows it to either impact the initial probability that the ensemble produces more or less. Henceforth, the whole point of the reliability going into this, or reliability modeling. So let's jump into this. Model 1 had the Marlins at a 56%. That's only been hitting 50% of the time. So Model 1, Marlins 50%. Model 2 had the Marlins at a 62%. That's only been hitting 54.55%. So Marlins 54.55. Model 3 had the Marlins at a 58%. That's been hitting at a 61.63%. So Model 3, Marlins 61.63. Model 4 had the Marlins at a 54.27. That's been hitting at a 58.73%. So Marlins, Model 4, 58.73. Model 5 had the Diamondbacks at a 54.73. That's been hitting 48.57% of the time. So Model 5 is the Diamondbacks at a 48.57. Model 6 had the Diamondbacks at a 51.17. That's been hitting 61.54% of the time. So Model 6 is the Diamondbacks at a 61.54%. Model 7 is the Diamondbacks at a 55%. That's been hitting 56.25% of the time. So Model 7 is the Diamondbacks at a 56.25. Model 8 had the Diamondbacks at a 52.7. That's been hitting 50% of the time, so both teams for Model 8 are 50%. And lastly, Model 9 had the Marlins initially at a 55%. That's only been hitting at a 42.5% rate. So Model 9 has the Marlins at a 42.5% probability. So after all that, what the ensemble model initially produces is the Marlins to win at a 52.26% probability. Now, when my ensemble model produces 52.2, or not 52.26 specifically, but 52% probabilities, those have only been winning at a 48% win rate. So using empirical Bayes calibration, which takes into account the ensemble model's initial output and the amount of sample size that the actual result has, which in this case is at 48% win rate, it calibrates based on the reliability of both. So the more sample size we have, the more reliable now just the real world empirical data becomes. So we can just calibrate further to what's actually happening in the real world. Whereas if you don't have as much sample size, that still plays a huge role, but not as much as it would if you had thousands of games. So you're still taking also into account what that model's initial prediction is, being in that 52% probability range. So saying that, 48% win rate when this gets produced, Marlins in the second layer calibration become a 50.42% probability. Now we take into account the market region of both teams here using that third layer calibration. The Diamondbacks aligned themselves today with a market region that has a 61% win rate. So for the Diamondbacks, very advantageous regardless to the market in general. 61% win rate, very good, but relative to their pricing as an underdog, extremely advantageous. Relative to Miami, this is very contrarian, especially to their pricing with them being a favorite. So what this does, we apply this calibration. This finalizes the Diamondbacks at a 53.62% probability, kind of bringing us back full circle. I got them at plus 108 odds, though the odds have not moved in my favor today, so you could probably get them now at even better odds, which I would highly recommend. You can recalculate the expected value based off that. The probability still holds true, but the market is not agreeing with this pick today, which happens a lot, honestly. Happened on my Blue Jays pick. The market moved over 12% in the other direction, and the Blue Jays won 7-2 against the Braves. You want to have positive closing line value. My model right now has been beating the closing line 60.34% of my bets, which is good. But my model is inherently very contrarian. So a lot of the times it's just going to be a lot more difficult to beat the closing line because I'm consistently betting against favorites, or I'm betting on cheap favorites. So again, I got the Diamondbacks plus 108 with a 53.62% probability, denoting a positive expected value of 11.53%, exemplifying both mathematical edge with the 53.62% probability, but financial edge with that expected value being 11.53% positive, risking 2.13% for a potential profit of 2.3 units. As always, if you want access to all of my free sports betting picks, you can go to my X account, NickTheQuant44. I post all my picks there daily. I post about the risk, the expected value, all that. I post my thoughts, updates, anything. My Instagram account is pretty secondary for me. That's where I just post daily results on my Instagram story, and then I post some infographics and more insight regarding the highest mathematical edge picks specifically. And then here on my YouTube is where I do my analysis videos to help you guys understand the math that goes into specifically the highest mathematical edge picks. But God willing, this continues to do well, and I build this, I scale this company to what I want it to be, and it is just my job, and I'm helping all of you guys perform really well. Well, then I'll have analysis on literally everything, but there's only so much time in the day that I have right now. I got to keep building. So again, thank you guys for watching this video, and yeah, let's tail. Good luck.